Agriculture is an important sector in Malaysia, although the overproduction has resulted in large amount of waste with inefficient disposal system. This video will study the wastewater control system by reverse osmosis using PID controller. The environmental analysis discovered this approach improved facilities efficiency. The challenges in this control design includes determining the appropriate control system, and the recommendation for zero waste notion to be adopted to treat the waste before disposal will be further discussed in this video.
Agriculture industry is a part of the main industry in Southeast Asia due to its favorable state for plantation. However, large plantation of the product cause ample amount of waste material emerge from this industry. In our project, we have chosen reverse osmosis to be our waste filtration system, as reverse osmosis has been demonstrated to be an excellent and cost-friendly process that for renovation of a wide range of waste. The major problem of this abandoned waste is the improper disposal system, where most of these agro-based wastes are intended in landfill or disposed in uncontrolled way. The objective of this project are to study the wastewater control system, to discuss on the suitable control system in reverse osmosis, and lastly to explore the challenge due to the implementation of the control system in agriculture.
In agricultural, wastewater treatment facilities has integrated various combination of processes in order to achieve the desired water quality. In this study, it will be focused on the effect of feed pressure and feed flow rate by manipulating valve position in retented stream and high pressure pump capacity, as it can affect on the net driving force and stage cut of the system. To conclude, the set point must fix at optimal value of feed pressure and flow rate to maximize the performance of RO. Thus, proportional integral derivative PID controller is chosen. The proportional action helps in stabilizing the gain of the system. Hence, high Kc is required for a faster response. Next, integral action helps in eliminating offset in the system with low value of tau I. Lastly, the derivative action helps in stabilizing and minimizing overshoots in the response. As for tau D, high value is required to reduce the oscillation. Nevertheless, too large or too small value of these parameters are significantly affect the oscillation speed and noise amplifier in the response. Therefore, all the tuning parameters must be set at the optimal value for better performance of PID controller.
The implementation of RO membrane ensures high effective water treatment. This means the wastewater plant can efficiently improve the water quality and sustain a clean water source. However, in order for the RO membrane to work, it requires optimal conditions, high feed pressure, low feed flow rate. In order for the wastewater plant to maintain the optimal condition, the proposed control system is required to be implemented. There are two possible outcomes. One is where the control system is applied, while another one is without the control system. If the control system is not implemented, the RO membrane will have a low removal efficiency, thus produce low quality water that will be discarded to the environment. On the other hand, the implementation of the control system shows the control system maintain RO membrane at optimal condition, which is why the RO membrane can possess high removal efficiency and treat the water effectively. However, it does have its own side effect. The control system is installed to the RO membrane to maintain the optimum condition as mentioned before. This means the plant is required to operate at high pressure, consume a large amount of energy. The amount of energy consumption contributes to a large amount of carbon footprint, which also lead to other bigger problems such as global warming potential and acidification potential.
In order to preserve the water quality and achieve zero waste, several challenges are prioritized in the process control system. The challenges are choosing the suitable control system, managing the control variables, and also managing measured variables in the feedback closed-loop system. However, using PID controller also has its own drawbacks. Firstly, the PID controller only functions best if the system has only a single input and single output, whereas in our reverse osmosis process, there are two control variables and two manipulated variables. Even though the PID is manageable to be used for multiple inputs and outputs, the method is very complex depending on how the variables correlate with each other. Other than that, it's costly in terms of budget, labor, and downtime. Changes in process load will also lead to changes in process dynamic, which requires an expert user to recalibrate the PID controller gains. Lastly, tuning the PID controller is also complex and tricky, where stability and optimal overall performance goes hand to hand. Other than that, the main concern in wastewater treatment are said to be aeration control. One of the issues with aeration control is the energy cost, which is the largest energy cost in the treatment facility. The aeration control should be prioritized, as the control amount of DO could affect the recyclability of activated sludge in the treatment process, the energy consumption, as well as the requirement quality of treated water.
Now for the recommendation part. Since the PID controller is only best for single input and output, that problem can be solved by utilizing cascade control, which is utilized for processes with more than one measurement but only one control variable. This control system utilizes two PID controllers, where the output of the primary controller determines the set point of the secondary controller. In this case, the primary controller controls the feed flow rate, while the secondary controller controls the feed pressure. Next, in order to reduce the cost of maintaining the control system and also ease the tuning process of the controllers, process simulation software can be utilized, while it also prevents mistakes from occurring in the real process. Next, using correctly sized blowers can help reduce the energy consumption of the aeration process. Blowers are equipment typically used to provide aeration in an activated sludge plant and are also utilized to promote aerobic digestion. So an optimum turn-down ratio for a blower utilized in an aeration system is at least 5:1. So an turn-down ratio is the ratio between the maximum flow rate and the minimum flow rate. Therefore, in order to increase this turn-down ratio, it can be achieved by reducing the size of its aeration blowers.
In conclusion, this study addressed the topic of agricultural waste by using a filtration that must be set up to treat it before being disposed by utilizing the reverse osmosis technique. The most important aspect is indeed the pre-treatment, and it is highly energy efficient, cheaper and ease of operation. It is possible to discover the difference between the measured variable and the set point by utilizing PID controller, as it is the ideal controller to employ in the reverse osmosis process. Challenges associated with implementing this method include selecting the best control system, controlling the parameters we wish to regulate, and managing the variables monitored in the process feedback system. Budget, labor, and downtime costs associated with the PID controller in the reverse osmosis process has also been considered, as access to clean water, sanitary conditions, and hygiene are among the most fundamental requirements for human health and welfare. This study may undoubtedly contribute to the achievement of Sustainable Development Goal 6 for our future betterment.